And then there was just some future studies that were coming out. So it was diclonide, I think that's how they say it. So it's an anaesthetic, and it was identified as a potential new treatment option. So it increases frataxin transcript and frataxin dose in FA cells. This is just an animal model so far. It affected chronic dosing in an FA mouse. A model prevented a performance decline in balance beam studies, which is pretty interesting. So they're going to do a clinical trial concept study. It's being completed in 8 FA patients, and then 6 of the 8 patients showed an increase in cell frataxin levels. So they're going to do further studies being planned currently. Just a little bit of background about the drug. So it's a local anaesthetic that they use in like bronchoscopies, laryngoscopies. They're used topically for temporary relief of pain associated with oral mucosa or anogenital lesions. So it blocks impulses at peripheral nerve endings in skin and mucous membranes by altering cell membrane permeability. It actions on the cardiovascular systems, may cause depression of cardiac conduction. So I think that was one of the issues surrounding the use in FA patients as well. I think that's why it was such a small study to begin with, of only 8 patients. But it'll be interesting to see where they can go with that drug. And then they've got this pharmaceutical company, BioBlast, has come up with this BBFA, which is a protein replacement drug candidate. So it's a mitochondrial fusion protein, and it's been tested on FA mouse models, which showed the protein had successfully internalized into the mitochondria of FA mice and significantly increased mitochondrial function in the hearts of these FA models. And just a little bit of background about the drug. It's just an innovative mitochondrial protein replacement platform, which has the potential to target more than 100 diseases that are deficient or mutated proteins associated with mitochondrial metabolism. So in 2 different mouse models, BBFA rescued both brain and heart tissues, returning their activity to near normal function. BBFA induced weight gain, prevented the development of heart disease, and increased the survival of the mouse model. And then there was this bone marrow stem cell. So this had a little bit of excitement around it as well, actually. So the administration of stem cell mobilizing drugs may have the potential to be developed into a simple, non-invasive and effective neuroprotective and regenerative therapy in patients with FA. They've been shown to display strong neuroprotective properties and activate cell survival in mature neurons and in patients' cells, while also showing neurological improvement. So neuroprotection is an effect that may result in recovery or regeneration of the nervous system, its cells, structure and function. It is thought that there are many neurochemical modulators of nervous system damage. So it'll affect the area of the dorsal root, so in your brain, so the dorsal root ganglia, cerebellum and spinal cord. And then just background on that again for you. So just and they just were just saying that their initial studies have suggested that bone marrow stem cells offer protection to nerve cells and cells derived from patients with FA. These stem cells are also able to improve some of the metabolic problems with FA causes. So they think that mobilising stem cells present in the bone marrow of patients with FA may be a way of protecting cells within the body and thus reducing damage caused by the disorder. They have demonstrated that human bone marrow cells help correct the effects of the genetic mutations in cells derived from patients with FA, increasing the expression of the protein frataxin, which is obviously reduced in FA, and increase their resistance to cell damage. So there's already a few drugs which are used clinically, but mostly these are for diseases of the blood system, such as leukemia. But this, if they're showing it, that's a good thing for us, because if it leads to good evidence of their safety, then it will kind of accelerate their use for it in FA therapy. And then finally, just thank you to FAN for the opportunity and financial support in attending the IARC.
Thank you for going over there.
That's right. It was great.
Well, scientific evidence better you than us. Susie, have you seen all these slides?
I've seen them. I was actually wondering if maybe if you have some questions about how they work and if you want to know more about the mechanism, I can probably next time, if you want, prepare kind of a presentation to go more into the details if you want, because sometimes they're really scientifically written and it might be hard.
That's exactly what
So
I
I would be super happy to do that if I can help in explaining more what's behind the scenes.
That would be great.